All right, we've been looking at continuity in behavior and limits, and so we're going to look at in behavior. And in behavior, simply defined, is what's happening at the ends of the graph. What's happening on the left-hand side? What's happening on the right-hand side? That's in behavior. And as we move through the course, I mean, a lot of what we're going to be concerned with, um, as it pertains, obviously, we're going to be working a lot of problems. We're always going to be concerned about what's the domain and the range. And every now and then, we're going to take looks at continuity and in behavior and limits and um, also relative minimum and maximum values, which comes up in our next chapter section, relative and absolute minimums and maximums and rates of change. But let's take a look here, a quick look here at in behavior. So let's go through kind of a definition, if you will, so that we hear about in behavior. An in behavior of a graph of a function describes how a function behaves at either end of the graph. What's happening on the left-hand side, what's happening on the right-hand side. And that is that the in behavior is what is happening of f of x. Remember, f of x equals y as either x increases, let's say moving in a positive direction. Don't know if that's the right way. It's to my right as x increases, and to my left, or traveling left down the horizontal axis as it decreases, and what we call without bound. In other words, moving towards infinity, and being whether it's becoming greater and greater value, whatever that, or it's becoming more and more negative. So we're looking at in behavior as x moves either towards negative infinity or positive infinity. What's y or f of x doing? Is it headed in a positive or negative direction? And we can, coming back to limits, we can describe the behavior of a graph by using limits, and we'll take a quick look at that. So in terms of describing in behavior using limits, let's just say kind of look at how that goes. So limits. So if we've got an expression that goes like this, the limit, and most of the time you're actually going to see this underneath the word limit. Somehow I couldn't get that to go. But anyway, as x is moving towards infinity, f of x, y, is read the limit of f of x as x approaches infinity. This is the initial description. We'll have to complete that once we evaluate the graph. And also, with the expression f of x, as f of x is moving towards, and let's kind of pretend that's right under there, towards negative infinity, f of x is read as the limit of f of x as x approaches negative infinity. Now, we look at the left in behavior. So the left in behavior is going to be, obviously, as x is moving down toward the left, towards the left on the horizontal axis, as it's moving towards negative infinity, what is f of x or y doing? And our right in behavior obviously is the opposite, as x is moving to the right down the horizontal axis or moving towards infinity. What is f of x or y doing? So we'll take a look here. I think next is a couple of graphs. And so here we've got a graph, and we're able to complete this statement of the limit here that you can see right here and right here. Okay, so as f of x is moving down the left side, moving left on the horizontal axis, as it is moving to negative infinity, we see that y is headed in a positive direction. It is headed towards infinity, what we would call infinity. And so here we see this red right here, the limit of f of x. As x is moving towards infinity, as x is approaching infinity, f of x or y is going towards infinity. X is headed towards negative infinity. In this graph, y is headed towards infinity. And here on the right side, that's the left side. Here on the right side, as x is moving towards infinity, we can see that f of x or y is down below the horizontal axis, and so it is moving towards negative infinity. The limit of f of x as x is approaching infinity is negative infinity. Pretty simple. Well, let's look at another couple of graphs here. And in fact, if you would, I'm going to pause here for a moment, let you get out your calculators. And if you would, graph this expression here. Then we can look at and talk about what's happening here with the limit on end behavior. So let's graph this expression x cubed minus 9x plus 2. I'm going to give you a few seconds to do that. All right, so hopefully you got that graph by now. And if I'm looking on this side of the graph here, or this graph here, I should say, I can see that as x is moving towards negative infinity, that the end behavior, or f of x, or y, is also moving in towards negative infinity. And so I could then write that, if I can get that, let's see, limit. Well, that's no good. Let's try it again. Limit as x is approaching negative infinity, f of x is moving also towards negative infinity. All right, now here on the other graph, well, why don't you go ahead and, well, no, that's partially cut off part of that function equation. But regardless, here we go. We got x moving in a negative. As x is moving towards negative infinity, we see that f of x, or y, is going off into positive infinity. And over on the right side, our right end behavior, as x is moving towards infinity, well, f of x is moving towards negative infinity. And let's see, I wrote the right-hand side. That was the right-hand side of this. Let me write the left-hand side of this one, which would be, the right-hand side of this one, I'm sorry. As the limit as x is approaching infinity, f of x is going towards negative infinity. So what I wrote here for the limit pertains to the left end behavior of this graph. What I wrote for the limits here is relating to the right-hand behavior of this graph. Now, sometimes we won't be going towards infinity. We may be going towards a specific value. So as I indicated, as we are going towards, not always, our limit of f of x is not always headed towards either negative infinity or positive infinity, but sometimes it's approaching but never quite reaching a specific value. And we'll take a look at a couple of graphs on that. Make sure you got your graphing calculator ready. And we want to graph and then look at tables as we do these. Okay, so let's take a look at end behavior when the end behavior is actually reaching a specific value. So I'm looking here at the graph on the left. It's 3x minus 2 over x plus 1. So let's get your graphing calculators out and let's graph that. And then we'll take a look at that together. So take a few seconds and let's do that. Okay, so hopefully you've got that done. And I went ahead and graphed it, and I've already moved here to my table. And so let's take a look at this graph. And I guess before we look at the end behavior, I can see here, and also on my table when I see when I'm at the table where x is -1, I've got an error. So I've got obviously I've got a point of discontinuity at -1. But as I scroll up from my table, going in the negative direction, in other words, as I am moving x towards infinity, I can see that I'm getting closer and closer and closer to 3. In fact, I'm now at x equals -20, and I've got y, or f of x, at 3.2632. This is on my right-end behavior. I'm looking at this side of the graph right here. And so I could write that then as, let's see, the limit, excuse my handwriting, I'm trying to write parallel here, as x is approaching negative infinity, f of x is approaching 3. All right. Now let's look at as x is approaching positive infinity. So let's take my table, and I'm going to start scrolling down, down until I get x is equal into positive territory. And I continue scrolling down the graph, and I can see that I'm getting closer and closer and closer as well to 3. Right now I'm at x is equal to 20, and f of x, or y, is equal to 2.76. And so now I can write the limit on my right-hand behavior. Yeah, my right-hand behavior. The limit of x as x is approaching infinity, f of x is also approaching 3. It's getting close to 3, getting closer and closer and closer, but it's never quite reaching it. So my end behavior on the left, as x, the limit of f of x as x is approaching negative infinity, f of x is approaching 3. And on my right-hand behavior, as I should have a little arrow there so we don't get confused, as x is approaching infinity, f of x is also approaching 3. Now let's take a moment, and on the right-hand side of the graph, we got this -6x squared plus 4 over 2x squared plus x plus 1. Make sure you get your parentheses in here on both of those. I failed to mention it on the first. If you don't have your parentheses in, you're going to get a false value. So take a few moments, and let's graph this second equation, the one on the right. Minus 6x squared plus 4, all that in parentheses, over parentheses 2x squared plus x plus 1, close parentheses, graph it. Okay, so hopefully you've got something that looks pretty close to what we've got on the screen here. And again, I'm going to hit second table. I'm going into my table. And let's see, I'm going to kind of get myself at 0. Oh, I'm moving in the wrong direction. No matter, no wonder. Okay, I'm there. So at 0, f of x is equal to 4. And I start moving in the negative direction. And I can see that even here at -10, when x is at -10, I'm showing that y, or f of x, is equal to negative 3.12. And so if I were to continue moving in that negative direction, as x is moving into approaching negative infinity, so my limit as x is approaching negative infinity, let's rewrite that. My limit as x is approaching negative infinity, f of x is approaching negative 3. Okay, so now what about on my right end behavior? So there's my left end behavior. So I'm going to scroll back down my table, and I'm moving in the positive direction. Now I'm moving here where x is getting closer. I'm moving towards infinity. And I can see here, even at x, when x is equal to 10, excuse me, when x is equal to 10, y is equal to minus 2.83, rounding that to the hundredths digit. And so then I can determine that my limit as x is approaching positive infinity, the limit of f of x in this graph is also approaching negative 3. So here were two examples where the limit of f of x was not approaching either positive infinity or negative infinity, but was in fact approaching a specific value. There you go. We'll do some more practice.